Imagine living hundreds of meters beneath the ocean, no land, no rivers, no wells, and for weeks, the only water surrounding you is seawater. Yet inside a modern submarine, the crew can drink fresh water, cook, clean, and continue living as if they were on land. But there is a fascinating question. Where does all that fresh water come from? Our submarine cannot simply carry an unlimited supply of drinking water. Water is extremely heavy, and space inside a submarine is incredibly valuable. So instead, some submarines can take the water surrounding them and turn it into fresh water. Yes, the ocean itself can become the submarine's water supply, but turning salty seawater into safe, usable fresh water is far more complicated than it sounds. The system has to remove salt, control impurities, use energy efficiently, store the water, and distribute it throughout the vessel, and all of this has to happen inside a steel machine that may remain underwater for weeks or even months. So how exactly does a submarine turn seawater into fresh water, and how does that water reach the crew hundreds of meters beneath the surface? Let's go inside and follow the journey from ocean water to a glass of fresh water. A submarine could simply fill enormous tanks with fresh water before leaving port. But there is a problem. Water is extremely heavy. Every extra ton takes up valuable space and adds weight to the submarine that affects everything: buoyancy, storage, energy consumption, and the amount of equipment the submarine can carry. A long-duration mission can involve hundreds of people using water every day, drinking, cooking, cleaning, and other essential activities. If all of that water had to be carried from the beginning, the submarine would need huge additional storage capacity. Instead, engineers developed a much smarter solution. Use the ocean itself as the raw material. Seawater surrounds the submarine almost everywhere it goes. The challenge is turning that enormous supply into water the crew can safely use inside the submarine. A dedicated water production system takes seawater, processes it, removes unwanted salts and impurities, and produces fresh water. The system is carefully monitored because the water has to be safe and reliable, and this isn't just about drinking. Fresh water is a resource that affects the entire submarine. The more efficiently the submarine can produce and manage water, the longer it can remain underwater without depending on the surface. And that is exactly what submarine engineers wanted: not just a storage tank, but a miniature water factory hidden inside a steel vessel. Inside the submarine, seawater enters a carefully controlled system. At first, it looks like ordinary ocean water, but seawater contains salt, minerals, and microscopic impurities. It cannot simply be given to the crew, it has to be processed. The submarine's water production equipment acts like a miniature factory. Different systems work together to separate unwanted material from the water. One important method uses heat. Seawater is heated under carefully controlled conditions. Some of the water becomes vapor, while many dissolved salts remain behind. The vapor is then collected and cooled, turning back into fresh water. The principle is surprisingly similar to natural evaporation and rainfall, but inside a submarine, engineers have to make the process much more compact, much faster, and much more controlled. Every component has to operate reliably inside a demanding environment: limited space, saltwater exposure, constant machinery operation, and strict energy requirements, because producing fresh water requires power and energy. Is one of the submarine's most carefully managed resources, so engineers face a constant balancing act: produce enough water without wasting energy or taking up too much space. And this is where a submarine's water factory becomes truly remarkable. The biggest problem is the salt. Seawater contains a huge amount of dissolved salt, and that salt has to be separated before the water can be safely used. One way is through distillation. The seawater is heated, and part of the water turns into vapor, but most of the dissolved salt is left behind. The vapor is then collected and cooled. As it cools, it becomes liquid water again, fresh water. It sounds simple, but doing this efficiently inside a submarine is a major engineering challenge. Heating water requires energy, and inside a submarine, energy is extremely valuable, so engineers have to design the system very carefully heat that might otherwise be wasted can sometimes be recovered and used again. This makes the process more efficient depending on the submarine's design. Other water treatment technologies may also be used, but the basic goal remains the same. Seawater goes in, salt and unwanted material are separated, and usable fresh water comes out, but producing the water is only the beginning. Once the fresh water exists, the submarine still has to store it, move it, and make sure it reaches the people who need it. Once fresh water has been produced, it has to be stored inside a submarine. Every bit of space matters. The vessel is already packed with engines, batteries or power systems, food, equipment, weapons, life support machinery, and crew living areas, so the water has to be stored inside specially designed tanks that fit into the submarine's limited space. From these tanks, pumps and pipes distribute fresh water throughout the vessel. The crew needs it for drinking, cooking, cleaning, and other essential activities, but the submarine doesn't simply produce water once and forget about it. Water production, storage, distribution, and consumption are constantly monitored. The crew needs to know how much water is available, how quickly it is being used, and when more needs to be produced. This becomes especially important during long missions. A submarine may be far from land and unable to simply return for additional supplies, so the water system has to be reliable every hour, every day, and throughout the entire mission. But producing fresh water and storing it still leaves one major question: where does the submarine get the enormous amount of energy needed to run all these systems? And for some submarines, the answer is one of the most powerful technologies ever placed inside a vessel. Producing fresh water requires energy. And inside a submarine, energy is one of the most valuable resources. The vessel has to power navigation systems, sensors, lighting, pumps, computers, life support equipment, and the water production systems themselves. On conventional submarines, energy has to be managed extremely carefully, but nuclear-powered submarines have a remarkable advantage. A nuclear reactor can generate enormous amounts of energy for very long periods. That energy can be converted into electricity and heat, which supports many of the submarine systems. The reactor operates deep inside the vessel, inside a heavily protected section. It can continue producing power while the submarine remains underwater. That changes everything. The submarine doesn't have to surface simply because it needs more conventional fuel for its power system instead. The major limitations become things like food, maintenance, spare parts, and the needs of the crew. The ocean provides the raw material, the reactor provides the energy, and the water production system combines them to create something essential for human life: fresh water. But there is still another challenge. Making fresh water doesn't mean the submarine can waste it. Every liter still has to be carefully managed. Inside a submarine, water isn't treated like an unlimited resource. Every liter matters. The crew may have hundreds of people on board, and every person uses water throughout the day: drinking, cooking, cleaning, personal hygiene, and essential operations. So the entire submarine is designed around efficient seawater production is continuously monitored. Storage levels are carefully tracked, and distribution is controlled throughout the vessel. Some wastewater can also be collected and treated for appropriate reuse. This creates a carefully managed water cycle. Fresh water is produced, stored, distributed, used, and where possible, water is recovered. Instead of simply being wasted, the goal is to get maximum value from a limited resource. And this becomes even more important during long missions. A submarine cannot simply pull into a harbor whenever supplies become low. It may be operating far from land, hidden beneath the ocean for an extended period. That means the crew depends on the systems inside the vessel. Water, air, food, power, and temperature all have to be managed together. A submarine is therefore not just a machine that moves underwater. It is a self-contained environment designed to keep people alive far from the surface. The deeper we look, the more the submarine starts to resemble a small city, except this city is sealed inside a steel hull and surrounded by an ocean that humans cannot breathe. Inside, thousands of meters of piping carry water, air, and other essential resources. Power systems keep the machinery running, life support systems keep the atmosphere safe, water systems keep the crew supplied with fresh water, and every system is connected. A failure in one area can affect another. That is why submarine engineering requires enormous levels of reliability. There is no easy escape, no nearby highway, no airport, no emergency room, just a steel vessel. The ocean outside, the crew therefore depends on layers of backup systems, monitoring equipment, and highly trained specialists. Engineers constantly watch pressure, temperature, water production, power consumption, and countless other parameters. Even something as simple as drinking water is part of this enormous network. The submarine takes something that surrounds it in practically unlimited quantities, seawater, and transforms it into something essential for human life. Water isn't the only thing that has to be produced and managed on board. The submarine also has another critical challenge: fresh air, because while the ocean can provide the raw material for water, it cannot provide the oxygen the crew needs to breathe, and that is where the submarine's atmosphere control systems become just as important. The submarine has solved one problem, fresh water, but there is an even more important resource: air. A crew can survive without fresh water for only a limited time. Without oxygen, the problem becomes immediate, so a submarine needs a way to continuously manage the atmosphere inside its hull. One of the key processes is producing oxygen while controlling the carbon dioxide that the crew constantly exhales. On many modern submarines, electrolysis can be used to split water into its components. Electricity passes through water, producing oxygen and hydrogen. The oxygen can then be added to the submarine's atmosphere. The hydrogen is handled separately by the vessel systems, but producing oxygen is only half the job. Hundreds of people breathing inside a sealed vessel continuously add carbon dioxide to the air. Too much carbon dioxide can become dangerous, so specialized systems remove it from the atmosphere. Other equipment helps control humidity, temperature, and other contaminants. The result is an artificial atmosphere that allows the crew to live underwater for extended periods. Think about what that means. The submarine isn't simply carrying a supply of air and water, it is constantly managing the resources needed to keep a small population alive. Water, oxygen, power, temperature, and air quality are all connected, and the deeper the submarine goes, the more important those systems become, because outside the hull, there is no breathable atmosphere, no fresh water, and enormous pressure. Everything the crew needs has to come from the technology inside that steel shell. But there is another reason living inside a submarine is so difficult. Pressure. The deeper the submarine travels, the greater the pressure outside its hull. At the surface, the pressure is relatively low, but as the submarine descends, thousands of tons of seawater press against its outer structure, and this pressure acts from every direction. That means the submarine's hull must be incredibly strong. The pressure-resistant section is built from specially engineered materials and carefully shaped structures. Every joint, every weld, every opening has to meet strict requirements, because at great depth, even a small structural weakness can become extremely dangerous. Inside the submarine, the crew experiences a completely different environment. The pressure inside is maintained at a level suitable for humans. Outside, the ocean is pushing inward. Inside, the atmosphere pushes outward. Between these two environments is the pressure hull, a massive engineered barrier separating human life from the deep ocean. This is one reason submarine design is so complex. The vessel isn't just designed to move through water, it has to survive the enormous forces created by the ocean around it. And while the hull protects the crew, the systems inside keep them alive. Fresh water, oxygen, power, temperature, and air quality all have to work together, because once the submarine travels deep beneath the surface, there is no simple way to stop the mission and come back whenever you want. So the question becomes, how long can a submarine actually remain underwater? A submarine's underwater endurance depends on many different factors: its power source, its food supplies, its maintenance needs, and most importantly, the needs of the people. Unmanned conventional submarines have to manage their energy very carefully. Their batteries can limit how long they can remain submerged before they need to recharge. Nuclear-powered submarines are very different. Their reactors can provide a continuous source of energy for extremely long periods. That means the submarine doesn't necessarily need to surface just because its fuel is running low. Instead, the major limitations become things like food, maintenance, spare parts, and the physical endurance of the crew. Think about that. The ocean provides the raw material for fresh water. The reactor can provide the energy. The atmosphere systems can help manage oxygen and carbon dioxide, so the submarine can create an environment where humans can survive far beneath the surface for an incredibly long time. And that's what makes modern submarines so extraordinary. They aren't simply underwater vehicles, they are self-contained worlds hidden beneath the ocean. But eventually, every mission has to end. The submarine must return to the surface and reconnect with the world above the ocean. And when you realize how many systems have to work continuously just to keep the crew alive, the submarine becomes far more impressive than it first appears. And perhaps the most impressive part isn't the fresh water itself, it's the fact that a submarine can create an entire living environment inside a machine surrounded by one of the most hostile environments on Earth. Fresh water, clean air, electricity, temperature control, food, and waste management all have to work together. Every system has a purpose, and every failure can create another problem. The crew may be hundreds of meters below the surface, but inside the submarine, life can continue almost normally. People can sleep, eat, work, exercise, and perform their duties, while above them, millions of tons of seawater press against the hull. That is the real achievement of submarine engineering. It isn't simply about going underwater, it's about taking a small piece of human civilization and carrying it into an environment where humans were never meant to live. The ocean provides the raw material, the submarine provides the technology, and together they create something remarkable, a machine that can remain hidden beneath the waves while producing many of the basic necessities its crew needs to survive. So the next time you see a submarine disappearing beneath the ocean, remember, it isn't simply disappearing, it's taking an entire, self-contained world with it. And somewhere inside that steel hull, seawater is being transformed into something every human being needs to survive: fresh water. If you enjoyed this documentary, subscribe to the channel for more fascinating stories about technology, engineering, science, and the incredible machines that push the limits of what humans can build. And I'll see you in the next documentary.